Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. You are watching Math with Yasir Arafat, and we have to discuss a very important question or most repeated question of exercise 5.1. Now come to the question number 5. Show that the multiplication is a binary operation on S. Binary operation means under the given operation, the resultant belongs to the same set. It is called binary operation. It is also called closure property or closed on S here. So here we have two different methods to verify the question here. So we have to construct the composition table, or we can perform the direct multiplication as well. The name of this table is called the multiplication table or the composition table. So here we have to write down the elements of S which are given in the question here. 1, -1 and minus iota. 1, -1, iota and minus iota. So one by one we have to perform the multiplication here, and we have to prove when we have to perform all multiplication, the all results belongs to the set S, then we are able to say that the multiplication is a binary operation on S. So here 1 multiplied by 1, the result is 1. 1 multiplied by -1, the result is -1. 1 multiplied by iota, the result is iota. 1 multiplied by minus iota, the result is minus iota. That means when we have to multiply 1 with these all elements, so our results belongs to the same set. Now come to the -1. -1 multiplied by 1, that is -1. -1 multiplied by -1, that is +1. -1 multiplied by iota, it is minus iota. -1 multiplied by minus iota, minus plus, so it will be plus iota. Now here iota multiplied by 1, the result is iota. Iota multiplied by -1, the result is minus iota. Iota multiplied by iota, the result is iota square, and the value of iota square, it is equals to 1. So here we have to put -1, not the iota square. So now here iota multiplied by minus iota, the result is minus iota square. So that will be equals to minus iota square, it is equals to -1 minus plus. So iota multiplied by minus iota, it is minus iota square, and its value is 1. So we have to write down its value, not the iota square. Now come to the minus iota. Minus iota multiplied by 1, it is minus iota. -1 multiplied by minus iota, plus iota. Minus iota multiplied by iota square, again minus iota square, and the value of minus iota square, it is equals to +1. So write down the +1 here. Now minus iota multiplied by minus iota, it will be equal to plus iota square, that is equals to -1. So here we have to put the -1. So dear students, we have to perform all possible multiplication of the elements which were given in set S, and the result, all result belongs to the same set. That means the multiplication is a binary operation on S, and this property, in other words, we can say this property is called the closure property as well. So we can say that there exists, this is the symbol, there exists multiplication on, we can say that multiplication is a binary operation. So here multiplication on a is a binary operation. Binary operation on S. So that means the first part of the question is completed. Now question says, is it commutative or associative? So for commutative, so here for commutative, A into B will be equals to B into A. So just take out any two elements from this set here and verify for the commutativity. So this is -1, it is equal to -1. That means there exists commutative property. Now come to the for associative. For associative, A dot B dot C will be equal to A dot B dot C, means multiplication. So take out any three elements from the set here. So that is 1 minus 1 into iota will be equals to 1 minus 1. This is multiplication into iota. So this is equals to minus iota. It is equals to minus iota. So we can say that there exists the associative property. There exists an associative property. Associative property. So here, dear students, we have discussed a very important question here. Now come to the next question here. Now come to the next question here. 5.1 exercise, question number 10. Let S is equals to 1 omega omega square, omega being complex cube root of unity. Construct the composition table, it is also called multiplication table, with respect to the multiplication, and prove that associative law holds. 1 is the identity elements and each element of S has an inverse. So here first we have to construct the composition table here. Now come to the first we have to prove this is the composition table. It is also called the multiplication table, and the binary operation is multiply 1 omega and omega square, 1 omega and omega square. So now we have to multiply 1 multiplied by 1, the result is 1. 1 multiplied by omega, the result is omega. 1 multiplied by omega square, the result is omega square. Now omega multiplied by 1, this is omega. Omega into omega, omega square, and this is omega into omega square, it becomes omega cube. The value of omega cube, it is equals to 1. So here we have to write down 1, not the omega cube. Now come to the next element, that is omega square. So omega square multiplied by 1, that is omega square. Omega square into omega, again omega cube, the value of omega cube is 1, so we have to put 1 here. Omega square into omega square, it is equals to omega power 4. Omega power 4 means omega cube into omega. So the value of omega cube, it is equals to 1. So that means the value of omega 4, it is equals to omega. So here we have to write down the value, not the omega 4. So here, dear students, we have to perform the multiplication and the all results belongs to the same set. So we are able to say that the multiplication is a binary operation on S. So here multiplication is a binary operation on S. Now we have proved that the binary operation, multiplication is the binary operation on S. This table is called composition table as well, multiplication table also. Now we have come to the A part here. Question says prove that the associative law holds. So first we have to take out the all three elements here. For associative law, A dot BC will be equal to A dot B dot C. Dot means multiplication here. Now take out these three elements here. 1 into omega omega square equals to 1 into omega square. So that will be equals to omega cube. It is equals to omega cube. It is equals to 1. So that means there exists associative law, or associative law holds. So we can say that there exists associative law. Now the next point is 1 is the identity element. Under multiplication 1 is the identity element, and under addition 0 is the identity element. Identity element means under the given operation that number does not impact on the given numbers which are given to you in the sets here. For example, here if we have to multiply by 1, we will get 1. 1 multiplied by omega, there is no change. 1 multiplied by omega square, there is no change. That means under multiplication 1 is the identity element here. So we are able to say that 1 multiplied by omega, it is equals to omega, belongs to S. 1 multiplied by omega square, it is equals to omega square, or 1 into 1 equals to 1. So that means 1 is when we have to perform the multiplication with 1, these all elements. So this one doesn't impact on the elements. So we are able to say that 1 is an identity element. Identity element. This is the B part. Now come to the C part here. Question says the inverse of each element exists in set S. So inverse of 1, it is equals to 1 upon 1, that is 1 belongs to S. Inverse of omega, it is equals to 1 upon omega. So when we have to multiply omega square and divided by omega square, so that will be equals to omega square over omega cube. So omega cube, it is equals to 1. So the inverse of omega is omega square. So inverse of omega is omega square. And inverse of omega square, here the inverse of omega square, it is omega 1 upon omega square. So when we have to multiply with omega divided by omega, it is equals to omega over 1. That means omega. So the inverse of omega, it is equals to omega. So here that means each element of S has an inverse in S here. So C part exists here. That means A, B, C, these three conditions are valid in this question. Dear students, thank you so much. If you like this video, please share it and subscribe my channel Math with Yasir Arafat. Thank you so much.